350,000 cubic yards of cyclopean masonry, 280 feet, or 85 meters, of solid rock and concrete, rising out of a narrow gorge to choke the Salt River in the middle of the unforgiving Arizona desert. This is the Roosevelt Dam, officially constructed between 1905 and 1911. The official narrative paints a romantic, dusty picture of rugged men taming the wild frontier with nothing but pickaxes, dynamite, and thousands of mules dragging wooden wagons across the desert. We are told this is a triumph of the American pioneer spirit. But at the Titan Metrics audit desk, we do not audit romance. We audit the physical supply chain. When you run the corporate logistics of the Roosevelt Dam through the uncompromising laws of physics, mechanical engineering, and volumetric mass, the pioneer narrative shatters. How do you transport indivisible 20-ton solid steel turbine shafts across 60 miles of crumbling dirt trails using wooden wheels? How do you achieve perfect industrial tension calibration on a 1,000-foot steel cable suspended over a gorge before heavy mechanization officially arrives on site? Welcome to the forensic audit of the Roosevelt megastructure. Let us open the ledger.
Let us establish the geographical baseline. In 1905, the Salt River Canyon was one of the most inaccessible locations in the American Southwest. The supply lines stretched from the nearest operational railways, requiring a haul of up to 60 miles through violently hostile mountainous terrain. 60 miles of sheer cliffs, deep ravines, and solid rock. To bridge this gap from the western railheads, the corporate contractors blasted a single-lane dirt track into the side of the mountains, famously known as the Apache Trail. This road was unpaved, prone to catastrophic washouts, featured blind hairpin turns, and contained brutally steep gradients. Most notably, the infamous Fish Creek Hill, which presented an unrelenting 10% grade over loose, unstable gravel. This narrow, crumbling 60-mile dirt path was the sole logistical artery for one of the largest infrastructure megaprojects on Earth. The mathematical deficit begins immediately when we examine the raw materials. The construction of the dam required roughly 340,000 barrels of hydraulic cement. A standard barrel of cement in the early 20th century weighed approximately 400 pounds. That equates to 136 million pounds, or 68,000 tons of cement. Let us apply the wagon equation. A standard heavy-duty freight wagon of the era, pulled by a team of 10 to 20 mules, had a safe operating payload of roughly 3 to 4 tons on rough mountainous terrain. To move 68,000 tons of cement over the Apache Trail in 3-ton increments would require over 22,600 individual wagon trips. Given the 60-mile distance, a fully loaded wagon team navigating a 10% grade on a dirt road would take at least 3 to 4 days to make a one-way trip, and another 3 days to return. To deliver the required cement within the construction timeline, the Apache Trail would have to support a continuous, unbroken convoy of heavy freight wagons moving in both directions 24 hours a day for years. On a single-lane dirt road where 2 wagons could barely pass each other without one sliding into the abyss, this volume of traffic is a physical and logistical impossibility. The road would instantly become a paralyzed bottleneck.
The official historians recognized this mathematical collapse. Their solution? The narrative claims that the engineers quickly realized they could not haul the cement, so they simply built a massive industrial-scale cement manufacturing plant directly on the construction site. Problem solved, according to the textbooks. But this alibi is a logical dead end that only amplifies the anomaly. To manufacture 340,000 barrels of Portland cement on site, you require a heavy industrial facility. You require a colossal rotary kiln. Mainstream engineers will eagerly point out that a massive steel rotary kiln could be transported in curved steel plates and riveted together on site. We acknowledge the physics of 19th-century riveting. But the steel shell is not the anomaly. The anomaly lies in the monolithic castings. A heavy industrial rotary kiln rotates on massive, solid cast iron trunnion rollers. It is driven by colossal, solid steel riding rings and giant, indivisible drive gears. These are highly specialized, precision-machined monolithic components. You cannot slice a massive drive gear into 50-pound chunks for a mule to carry, and you cannot rivet it back together on site without destroying its structural integrity. These indivisible cast components weighed tens of tons each. How does a corporate contractor transport a 20-ton solid steel industrial gear across 60 miles of narrow dirt track? When you place a 20-ton concentrated payload on a 1905 wooden freight wagon, the physics of weight distribution become catastrophic. The axle load limit of wooden-spoked wheels with primitive iron rims is immediately exceeded. The axles snap, the wheels splinter into kindling. Furthermore, pulling 20 tons of dead weight up a 10% grade of loose rock requires a drawbar pull that living biological engines simply cannot generate. The friction coefficient of a mule's hoof slipping on dry Arizona gravel means that no matter how many mules you chain together, they cannot establish the necessary traction to move that concentrated mass. The kinetic energy required dictates that heavy, mechanized traction engines or rail systems had to be used. Yet the official public record insists it was all done by horses and mules.
But the cement mill is only a fraction of the mechanical paradox. The Roosevelt Dam was not just a wall of rocks, it was a state-of-the-art hydroelectric power plant. Deep inside the masonry, the contractors installed massive turbines and electrical dynamos to generate power. Let us audit the hydroelectric supply chain. A commercial-grade hydroelectric plant from the early 1900s is a marvel of heavy foundry casting. The anomaly lies in the heavy mechanical linkages and penstock systems. The grid requires solid forged steel turbine shafts and massive cast iron water valves. These are highly specialized, precision-machined monolithic components. A single structural component from that era routinely weighed 15 to 20 tons. You cannot slice a massive forged turbine shaft into 50-pound chunks for a mule to carry. We are expected to believe that 20-ton blocks of solid forged steel were casually loaded onto wooden wagons and hauled through the desert. Let us run the physics on that scenario at the Fish Creek Hill gradient. If a wagon weighing 20 tons is attempting to climb a 10% grade, gravity alone is pulling 2 tons straight backward down the hill. That does not account for the extreme rolling resistance of narrow iron wheels sinking into soft dirt and gravel. To overcome gravity and rolling friction, the mule team must exert a massive, constant, forward dynamic force. If the wagon hits a rut or a rock, the momentum halts. To restart a 20-ton dead load on an incline requires a spike in torque that flesh and bone cannot provide. If the team stalls, the wagon rolls backward, dragging the mules over the cliff. The official timeline asks us to believe this mechanical miracle occurred smoothly, repeatedly, and without mechanized winches or heavy rail infrastructure.
Before they could pour the concrete or set the heavy stone blocks into the riverbed, they had to move materials over the gaping void of the canyon. The official narrative states they installed an advanced, heavy-duty industrial cableway system spanning 1,200 feet across the gorge. Let us audit the kinetic physics of the cableway. Suspending a thick, multi-strand industrial steel cable across a 1,200-foot abyss is a monumental engineering feat. A steel cable of that gauge weighs several tons. Before the cable can even be tensioned, it sags violently under its own dead weight. How did unmechanized laborers drag a multi-ton steel cable across a bottomless gorge,
pull the immense slack out of the line and anchor it into the canyon walls with absolute perfect tension. Today, you use helicopters, laser telemetry, and heavy diesel winches. In 1905, they supposedly did it with pulleys and sweat. Even more absurd is the power required to operate this cableway. To lift 10-ton cyclopean stone blocks from the canyon floor and swing them through the air requires massive electrical winches. Mainstream historians claim they solved this by building a temporary small hydroelectric power plant on site to run the cranes. This is a circular paradox. To build the temporary power plant, you must import massive, heavy steel turbines. To import the turbines over the impossible terrain, you need the heavy cableway. But to run the cableway, you need the electricity from the power plant. The narrative contradicts its own sequential logic.
Now, we must factor in the consumable burn rate. This is the silent killer of all historical construction myths. Let us assume, against all laws of physics, that the wagons could move the solid steel shafts, the kilns, and the steam winches. What is powering the site itself? If the cableways, the rock crushers, and the cement mill were operating on steam power before the hydroelectric grid was online, they required continuous, massive amounts of fuel. The on-site cement kiln alone required temperatures of 2,700 degrees Fahrenheit to calcine the limestone. The record states they burned crude oil and wood. Where did this fuel come from? It had to be hauled up to 60 miles by wagon. If the massive industrial steam engines and the kilns burn dozens of barrels of oil and tons of wood every single day, that requires a dedicated fleet of wagons doing nothing but hauling fuel. Then we have the biological engines, the workforce. 2,000 men and roughly 2,000 to 3,000 horses and mules lived in the Salt River Canyon during the construction. Let us calculate the biological logistics. A working draft mule operating in the extreme heat of the Arizona desert requires approximately 25 pounds of feed, grain, and hay every single day. Multiply 25 pounds by 2,000 mules. That is 50,000 pounds of animal feed per day, 25 tons. A standard wagon hauls roughly 3 tons. That means 8 fully loaded freight wagons must arrive at the dam site every single day just to keep the animals from starving. 8 wagons in, 8 wagons out, every day. Now add the fuel for the massive steam winches. Add the oil for the kilns. Add the food for 2,000 men. Add the timber required for miles of wooden scaffolding. When you tabulate the daily consumable burn rate of the Roosevelt Dam project, the sheer tonnage of food, water, coal, and oil consumes 100% of the Apache Trail's theoretical traffic capacity. The road would be completely saturated just keeping the engines burning, the workers breathing, and the animals alive. There is mathematically zero logistical bandwidth left over on that single-lane dirt road to transport 20-ton steel gears, heavy steam dynamos, or millions of pounds of structural iron. The entire corporate timeline is mathematically irreconcilable. We are looking at a logistical deficit of staggering proportions.
So, what is the physical reality? We do not subscribe to myths of magic. We do not evaluate unproven theories. We track the corporate reality. The reality is that the early 20th century corporate conglomerates who built these megastructures had access to heavily guarded, highly advanced industrial mechanization. The physical evidence dictates the heavy reliance on steam traction engines and localized rail networks. The official ledger admits heavy steam tractors were present, but casually dismisses them as failed experiments, claiming the mules did the real work. This is corporate misdirection. They downplayed the heavy mechanization to maintain the romantic pioneer narrative and protect proprietary construction logistics.
History is a ledger written by the victors, and in the early 1900s, the victors were the patent holders and the industrial monopolies. To admit that these projects required heavy, advanced mechanized infrastructure that contradicted the public image of the rugged mule-driving pioneer was bad for the brand. And more importantly, it was bad for maintaining strict corporate monopolies on specific heavy engineering techniques. They hid the tools, they minimized the machinery, and they left us with carefully curated photographs of a few dozen mules standing next to a dam that physically requires an industrial railway to exist. They didn't build the Roosevelt Dam with wooden wheels and hay. They built it with highly classified heavy industrial mechanization that the official ledger refuses to fully acknowledge. The math does not lie. The mules did not move the mountains. The physical supply chain is broken, the volumetric displacement is impossible, and the official timeline is mathematically irreconcilable. To our current auditors and new viewers joining the ledger, thank you for your continued focus. Hit the like button to bypass the algorithm's suppression and leave your localized architectural anomalies in the comments below for future deployment. For our full forensic breakdown of corporate infrastructure laundering, the file is on your screen right now. Trust the numbers, not the narrative. The ledger remains open. If you want to support these ongoing structural audits, the Oversight Committee is officially open. Click the Join button below to receive your security clearance and become a field auditor.